This is going to be a quick 30-minute session, but if we need to go a little bit over the 30 minutes for today, we can do that. If you have any questions, you can put those in the chat or just wait and we'll have time to voice those at the end. And if you're on Zoom, then you figured out the registration here. If you're watching this later or on Facebook right now, the registration link is right here through this bit.ly link. And I'll move to the next one here. So my name is Becca Trueman. I'm the Watershed Coordinator for Currys Fork Watershed. I'm an employee through Oldham County Fiscal Court. And our Currys Fork Watershed Program is a watershed-based effort to improve polluted waterways. The Currys Fork Watershed, as you can see here, is completely within Oldham County. So some of the work that we do includes stream restorations, streamside planting, septic system repair, rain gardens, workshops like this one, and more. We have a local watershed group called Friends of Currys Fork, and everybody is encouraged and welcome to join us. We currently meet on the third Wednesday of each month at 10 a.m. on Zoom, and we'll expand out into more in-person events as we are able to. The best way to contact me is via email as well as on our Currys Fork Watershed Facebook page. And then, as I said, this is the second of 3 events that we have here. The next one is next Thursday, the 4th. That's going to be focused on inspecting and maintaining green infrastructure. And if you miss any of these, the recordings can be found, as I said, on our Currys Fork Watershed Facebook page. And then David Gamstetter with Davey Resource Group is presenting these topics for us. Dave is a project developer for Davey Resource Group. He's responsible for building relationships with public and private partners to provide services for installing, maintaining, and inspecting green infrastructure structures and systems. And Dave has extensive experience in urban forest management, invasive plant species control, park management, street and park tree master planning, and horticulture. And then Davey Resource Group is out of Cincinnati, and the contact information is right down here. So I'm going to stop sharing my screen, and Dave, I'll let you start sharing your screen.
Thank you. Hello, everyone. I am a business developer with Davey Resource Group, and my specialty within the company is green infrastructure. So if you were able to join us last week, we talked about kind of landscape scale stormwater solutions. And today I'm going to continue on that theme. The presentation I'm doing today is one that I put together last fall for the Claremont County Soil and Water Conservation District. They're in suburban Cincinnati on the east side of town, and their conservation district manages the MS4 permitting process for the townships and the communities within their county. So they asked me to come and present as part of the MS4 training process. So today I'm going to talk a little bit about MS4s. I'm going to talk a little bit about structure of our communities and how development impacts stormwater quality and quantity. And then we're going to talk a little more specifically about different vegetation cover types and management strategies that you can do to minimize the amount of runoff, as well as increase infiltration and improve stormwater quality. So I am going to start with what is a watershed. So it's a land area that channels rainfall and snowmelt to creeks, streams, and rivers, and eventually to outflow points such as reservoirs, bays, and the ocean. So most of our region, the water drains ultimately into the Ohio River and then into the Mississippi. So what impacts that? Well, if we look at a green area, a green system area with plant cover types, more like our native vegetation types would be, We get 40% of the rainfall that hits the ground is evapotranspired through the vegetation. 25% gets infiltrated into the shallow root zones and 25% into the deeper root zones. If we just increase our impervious surfaces through development by 10 to 20%, we reduce evapotranspiration just a little from 40 to 38, but we start to see more percentage reduction in shallow infiltration and deep infiltration. And if we look at more build up areas, like if we think about downtown Louisville, if we get 75 to 100% impervious surface areas, we get 30% evapotranspired, mostly off of parking lots and roofs and stuff, but only 10% is infiltrated and 5% goes into deep infiltration, more like what would be used to replenish an aquifer. So development is a primary impact on stormwater in our urbanized communities. Well, what does that mean? Well, if we have 18% imperviousness, and if we go back to the previous slide, we are looking at something that is not a whole lot. I mean, that would be a typical residential subdivision. We're looking at 10 to 20% impervious surface. So that impact is not that great when we look at just native vegetation cover type. So, but 18%, we're already seeing the aquatic diversity of our streams declining. And then when we get to 40%, we have active stream widening, which increases erosion and pollutant loading. And then at 60%, it's massive erosion. The natural channel can't be maintained. So where does it go if it does run off? In most MS4 communities, rooftops, lawns, driveways directly connected to local creeks and streams, and ultimately Ohio River, and they form the headwaters of our urban stream system. So it's our responsibility to give our streams a clean, healthy start. So I love this cartoon. I mean, it pretty much shows you visually what happens when we put things into our stormwater inlets. I mean, it has a direct impact on our streams. So there's a lot of programs for you know, marking dedicated stormwater inlets so that people understand that it's going straight to the stream. It's not being treated. You know, we all know of people or situations where things get washed into there, motor oil, that kind of stuff. So it's not, might be out of sight, out of mind, but it does have impacts downstream. So our stormwater is regulated under the Clean Water Act. Specifically in 1987, there was an amendment to the Clean Water Act that covers non-point sources such as stormwater runoff, municipal storm drains, and other sources that weren't addressed in the 1972 legislature that created the Clean Water Act. And municipal separate storm sewer systems, MS4s, have to obtain National Pollutant Discharge Elimination System permits. What does that mean? Well, communities in MS4 areas have to implement 6 minimum control measures. Number 1, public education and outreach. So today's presentation, as I said before, was one I did specifically for public education and outreach for Claremont County, Ohio. The second one is public involvement and participation. The third one is illicit discharge detection and elimination. The fourth one is construction site runoff control. The fifth one is post-construction stormwater management. And then the sixth one is pollution prevention and good housekeeping for municipal operations. So that's a lot. I mean, you know, some things make perfect sense, and then some things are a little more obscure, like what does post-construction stormwater management mean? Well, that is maintaining the structures and the systems put in place to manage stormwater. And then pollution prevention and good housekeeping for municipal operations. That's kind of what we're going to talk about in today's talk. So communities and MS4s develop and enforce ordinances for resolutions, ensure stormwater control measure function, maintain publicly owned stormwater control measures, and landowners maintain privately owned stormwater control measures. Those would be basins on private property and other types of green infrastructure. So I'm a firm believer in using natural systems to for sustainable property management as much as we can. Try to replicate those. They work perfectly well in nature. And so with a little bit of thought, we can make them work within our communities and urbanized areas. So I want to talk more about infiltration rates by land cover. So the greatest amount of infiltration happens in our native forests, where we have tree canopy overstory. Typically we have an understory tree canopy of smaller trees and shrubs, and then there's an herbaceous layer. And if we walk in the forest, we know the soil is spongy and full of humus and organic materials, and it works very well as a sponge in absorbing stormwater and letting it perk through to into the soil. The next one is pasture. We can look at pasture and cropland, and what's the difference? Well, pasture is covered with plant vegetation year round. Cropland typically is tilled. Even if we use no-till or low-till technology, we're still disturbing the soil. There's times when there's going to be quite a bit of surface runoff, but we're still getting some infiltration there. The plant material is holding the water in place and slowing it down and allowing it to infiltrate. Next is bare earth. So with no vegetation, it's definitely going to be less than cropland, where we have vegetation parts of the year. And next is buildings and then pavement, where we have almost zero infiltration rate. So when we talk about plants, we think intuitively, oh, we have lawn, we have grass, we have turf grass. But native plants actually provide the best bang for the buck for stormwater control management. They develop much deeper root systems, which does a couple things. One, as they grow, they penetrate the soil and make it easier for water to go through. Secondly, they build the soil up as the plants die or roots die off, and then they decompose. They're down at the level where they're going to start actually building up the soil. They slow the runoff, increase infiltration, prevent erosion, and a great habitat for birds and butterflies. And we'll talk about goose barriers here in a minute. And then if we look at just what is the difference between turf grass and native plants? Well, with turf grass, we get 72% runoff with 28% infiltration. But with native plants, we get 12% runoff with 88% infiltration. That's a really simple thing that we can do, taking areas of our lawn out or in community parks and replacing it with native plants such as prairies, grasslands, tall grass prairies. You can mix in some wildflowers and get more diversity, and the public accepts these. They understand what they are, and it's a big improvement, not just in aesthetics, but for wildlife and the park experience. So then we also talk a lot about detention basins and some of the issues with maintenance. You can see they're trying to maintain the turf all the way down to the edge, and what they have is erosion along there. It's difficult to mow, especially during the rainy season in the spring. I've seen horror stories where people get mowers stuck. I worked for Cincinnati Parks for 30 years, and we had issues like this. And if there's tall grass, people don't want to get out there with a string trimmer and do the work. They want to mow it as close as they can, and it just causes all kinds of issues. But if we, instead of having turf, we change that and plant native plants that can handle wet feet in full sun situations, we get the improved benefits of having the natives there. We get the improved benefits of having wildlife habitat, and geese don't want to go there and nest and become a nuisance because they don't like the higher vegetation cover. So you know, when people talk about having problems with geese, the simplest thing to do is stop mowing and plant something different, and it takes care of the problem. We talked about the best opportunity to increase infiltration is through forested areas, and streamside forests are the best, absolute best bang for the buck, because not only are we getting the value for infiltration and we're getting all the other benefits of trees, the carbon storage, evapotranspiration, wildlife habitat, and most importantly, oxygen. We also reduce the amount of erosion. The leaves that fall into the stream improve habitat. That's what the lower feeding insects feed on. That begins the food chain for other animals such as amphibians and fish. And the trees shade the water, which increases its capacity to hold oxygen. So a simple thing that you can do is, if you have mowed areas adjacent to streams, is take those out and look at streamside buffers. The other thing that we view as an issue is our invasive plants. If you look at the little key map up there, our part of the country is the epicenter for Asian bush honeysuckles. And there's multiple problems associated with it. You know, the first one is it has a very long growing season. So the leaves come on before our natives and then stay on past the time of our natives, and thusly are able to begin to outcompete them. Secondly is they're allelopathic, which means the plants exude chemicals that prevent other seeds from other species from germinating beneath them. And so what happens over time, if you have a dense patch, is they create a bare soil situation. And this increases the amount of surface runoff by a lot. First, you know, not having other understory plants beneath there, but just total bare soil. And if we look back, bare earth is, you know, it's at the lower end of the infiltration rate scale. So what can we do? We use a tool called ITREE to model the effects of having honeysuckle in one of our watersheds in Cincinnati, Ohio. ITREE is a free tool. It's a tool that you can download, and you can actually do different measurements of the benefits of vegetation on a given piece of land. So, for example, you could model how much carbon the trees on your property store, or their sequestration rate, their annual rate. You can also model energy savings if it's within, you know, proximity to a building, a structure that's heated or air conditioned. So it's a really, really cool tool that allows us to communicate the value and benefits of the vegetation, the trees that we have on the site. So what we did with that was we used it to model this watershed based on actual rainfall and flow data out of the stream at the lower end of the watershed. And we were able to isolate out honeysuckle, which I will get to those results here in a minute. And the way that this works is you create, first of all, ITREE can be used as a standalone, so you can do it on your desktop at home without having GIS, but you can also use it to model the value and benefits of trees on a landscape scale basis. So for example, in Cincinnati, we do a tree canopy study every 10 years. We fly the city with true color digital orthophotography, and then classify, sort out the different vegetation cover types, whether it's turf, it's trees, it's impervious structures, it's buildings, water. And then with ITREE, we're able to map and model the benefits of those trees. So for example, Cincinnati's urban forest provides $42 million a year in annual pollution removal and stormwater abatement benefits. So what that means is how much gray infrastructure would need to be built in Cincinnati, Ohio to handle all the additional stormwater that's going to run off if we cut down all of the trees. And what does that cost per year, prorated over 20 years? So that's part of it. And another part of it is what is the actual cost to remove the amount of carbon that's produced that's offset by the trees, and the amount of nitrous oxide and all the other airborne pollutants that trees help abate. And looking at stormwater alone, the park system, which is in Cincinnati, the park system is about 10% of the area of the city. Just looking at the park trees, they provide over $5 million a year in annual stormwater management benefits. That's the cost it would be to build gray infrastructure to manage the stormwater over a 20-year period. But then you would also not be getting the other benefits. So back to the watershed study, we used ITREE Hydro. It's an application that can be only used with the GIS system. And it's designed for looking at urban vegetation effects so that you can make vegetation cover type changes or modeling to look at how one thing impacts another. So you can select a US city and simulate water flow and water quality changes qualitatively by modeling tree and impervious cover changes. And all the data is out there now. So they have all the watershed information, and you don't really need to have GIS skills to do it if you're using their data. And you can do your own analysis from your home computer. So this is the watershed that we looked at. This is Lick Run in Cincinnati. It's very developed, and it has the biggest combined sewer overflow contribution in the county. In Hamilton County, it's I believe 1 billion gallons of combined sewer overflows a year reach Cincinnati's Mill Creek, which then flows into the Ohio River, which is where, you know, hundreds of millions of people get their drinking water, which is really disgusting if you think about it. And then, so what we found when we looked at honeysuckle, we assumed that we would have a tree canopy overstory, and then we would have a shrub layer canopy of honeysuckle with bare soil conditions. And so we modeled this watershed with, you know, what if we took out all the buildings, all the roads, and we just put back trees? We would have 0% runoff. If we did that 100%. Obviously we can't do that. It's developed, there's neighborhoods, there's a Walmart, there's other stuff in this watershed. So what if we were to just take out the honeysuckle and replace it with native shrubs? We would have almost 2% reduction in flow if we just do that one thing. So we think intuitively that vegetation, you know, reduces the amount of runoff that we have, but it depends on what type of vegetation it is. If we take out the honeysuckle, we don't plant back shrubs, and we just take out the honeysuckle and allow the herbaceous layer, whatever seeds are in the soil there, to grow back, we get a 1.4% decrease in reduction. So what can I do in my community? Number one, plant streamside forest buffers. Like I said, if you're mowing, you got park space next to streams, the best thing to do, or even on private property, the best thing to do is plant trees. What else can we do? Raise up the height of your mowing deck just by increasing the height of your mower deck and allowing the grass to get taller, even if it's just turf grass, which we know doesn't do a whole lot for infiltration rates. It helps. The taller the grass is, the healthier the root system that grows deeper and allows water to infiltrate more. So even if it's taking an area of a park or your community and mowing it higher or mowing it less often with a higher deck, you're going to get increased benefits. Next, invasive control. If you take this out and plant it back with natives, you're going to be way ahead of the game. with surface erosion and stormwater quality as well as quantity. Look at your ponds and your ditches and detention retention ponds, swales, and plant native plant systems. You get multiple benefits, including clean stormwater and reduced or increased infiltration, wildlife habitat, and if it's next to a pond, it'll take care of your geese problem, guaranteed. So next, convert turf areas to native plants. Take areas of your park system that aren't actively used and convert them to natives. You'll be happy you did it. The public, when they see the wildflowers, they appreciate it, they understand it. A little bit of signage out there is always useful as well. And lastly, here's my contact information. I also, I work on the eco team that writes articles for our newsletter. If you'd like to be signed up for our eco newsletter, it comes out quarterly. And you can either give me your name and where you work and your email address in the chat. You can add it there, or you can email me separately at david.gamstetter@davey.com. And I would be happy to sign you up for that. This next year, I'm doing 4 series on vegetation. The first one is vegetation specific to bioinfiltration basins and green infrastructure basins. These are plants that are able to handle water inundation, but also dry feet, because as you know, these things, most of them are designed to drain and dry out. So we also are serving this market now. We're in, we go as far as Louisville and Lexington. And these are some of the services that we provide. If you have a need for any of these in your community, reach out and I'll be happy to talk to you about that. And my phone number is listed as well. So that's what I have. Thank you.
Yeah, thank you for that. That was a lot of really good information. Does anybody have any questions for Dave?
Yes, I do. Should I remove all the honeysuckle in my yard? Try to.
Definitely. Definitely. It's not easy. The best time is in the fall. Cut it off at the ground and right away brush on a 10% mixture of glyphosate. That's something that homeowners can buy. Be careful with it. You know, it's becoming more and more, there's more and more concern about the safe use of it. Make sure you wear rubber gloves. But it's, you know, it's pretty effective if you do that in the fall when the plants are starting to go dormant, because they're pulling all their nutrients and sap back down in the root system. So you get a better kill in the fall.
Okay. Thank you.
Any other questions?
I hope everyone signs up for our newsletter. There's always interesting articles in there about, you know, different aspects of natural resource management, or you know, interesting, cool projects that we're working on that might be able to be replicated in your community. Like I said, that's quarterly.
Jim, did you have a question? You're muted right now if you do.
How's that? That work?
There you go.
We have a problem with distributed runoff from the local fields. We have had an army of people run out during rainstorms, and I have a picture I could show you. I was wondering if you could comment on any ways that we might be able to approach the local farmers and landowners about what they're doing to our lake. Maybe I could show a picture. I don't know how to do that. Share
I
screen.
believe you can share
What's the-
your screen if you'd like.
How about this? Can
Yeah,
see
you got
that?
it. Mm-hmm.
So that's Crystal Lake here in LaGrange. And that's just after a rainstorm, and it takes a couple hours for the silt to work down. But we trace this all the way back upstream until it disappears into a bunch of cropland areas. And it's so distributed, you can't really tell until it goes into a culvert where it's coming from. Any thoughts?
Yeah, there's a couple. One would be having a discussion about having a buffer between the tilled areas, the planted areas of the farms, and where it drains into in the watershed. I'm assuming it flows into a stream.
Yeah,
so that would be the first thing.
I'm sorry.
Yeah, that's the first thing I would do is try to get some kind of a planted buffer of native plants with some, some grasses and prairie plants in there that are gonna filter some of that out. That's where I would start.
Okay, is there anything in the documentation that you talked about, the 1972, the Clean Waters Act or whatever, that would give us a little bit of teeth as we talk to these farmers and landowners?
No, I would start with your soil and water conservation district. They would be most familiar with the local laws and regulations as to what can be done, what can be encouraged. I know that Kentucky has a very active stream buffer program through their natural resource department. There might even be grant money available for the farmers to apply for that would help pay for something like that.
And this area of MS4, Becca, are we all MS4 here, or is there a map of MS4 territories? Or
yeah, I was actually trying to find it. I don't have the map. So the MS4 is it's the separate storm water. You have to remind me, it's the stormwater system. So basically, in short, when water is channelized somewhere, it's through some type of infrastructure. So that's a stormwater. We talk about pollution, we're talking about non-point source and point source. So the point source, that's the MS4.
Okay, because it talked about urban, and I wouldn't think that we're classified as urban, right?
So we are, yeah. So most of Oldham County is managed through the MS4 is managed through the Oldham County Fiscal Court Engineering Department. Okay. There are a couple of smaller MS4 programs within Oldham County. I believe probably Goshen and Pewee Valley are those, but I'd have to confirm that. Okay. But most of where we are is managed through Oldham County Fiscal Court. And then LaGrange, I believe, is also through Oldham County, but I'd have to confirm those as well.
Okay, thanks.
But I'm sorry, so the MS4, it's the Municipal Separate Storm Sewer System. To clarify,
I'm going to assume that we're covered under that. Okay, thank you.
Mm-hmm. Yeah, we
Thanks,
are.
David.
And then Jim too, as well, to speak to, and we can talk more about the ag stuff offline as well, but all farmers are supposed to have an agriculture water quality plan, and those are stored through the local conservation district. So conservation district would be a good place to go with that, like David said.
Yeah, I'm sure they would be very happy to look at your pictures and to help you out with that. They're, at least every conservation district I've ever worked with has been just great to work with.
Any other questions on here? I know some of this information might be, you might have heard it already quite a bit, and then some of it might be really new. So if anybody has any questions or you're looking for clarification or more specific assistance, please reach out to me and I'll be happy to talk with you and get you some additional resources. If you are not on the contact list I have for the community, feel free to put your email in the chat and I will get that. But if nobody has any additional questions, go ahead, David.
I was just going to say, next week, I'll be talking about inspecting green infrastructure systems. So it'll be a little more specific and focused than this one. You know, this one was more, again, more landscape based, so that'll be more system based.
Yeah, so our next one is next Thursday, same time. And I guess just a big takeaway to kind of like sum it up on a lot of this stuff is really we're just looking at incorporating native plants more into our landscapes. That's really the solution to help out with all these various pollution issues. So thank you so much, David, for this presentation. Looking forward to next week, and thank you all for joining.